Welcome all of you. So in this video, I will explain how to use the facing strategy in turning operation, that is lathe operation. So here in the browser tab, you can see under the setup option, you can see the facing strategy is created. So here this is the facing strategy. You can see tool number 1, CNMT T3. Here you can see tool is selected, everything is selected. If I will select this and I will go to simulate, here you can see the simulation. So here this is the facing operation. So facing means you have to remove the material from this front side of the part. This is called a facing operation. Okay, so how to create this facing strategy using Fusion 360. So I will explain in this video. So I will close this and I will delete this. I will delete this. Okay, so I will close this. Okay, so I will go to the data panel and I will click the home button. And here, when I click the home button, you can see the samples. Under the cam samples, double click on this cam samples. You can see the different cam files. So I will go to uh, tutorials. I will double click on this tutorial and then I will select this tutorial number 6. I will double click on this tutorial number 6. So here, this is your CAD model. So this is the first step. You have to create your CAD model. So now I have taken this CAD model from the library. So depending upon your job, you have to create your CAD model within the design workspace. So design workspace is used to create various CAD models. Okay. So then I will go to the manufacturing workspace. Okay. So before that, I have to change the units. So here you can see under the browser tab, you can see the document settings option. Under the document settings, you can change the units. Okay. Here I am actually using units as millimeter. Okay. If you want to change units like centimeter, millimeter, meter, inch, or foot. Okay. If you want to change inch, you can click, enter this inch and click OK. So now the unit is changed into inch. So I will change this into millimeter. Okay. Then I will save this. Okay. So before that, I will go to say home page and then I will click a new project. So I will name this folder as CNC Facing Operation. CNC Facing Operation. Okay. So I will create a folder CNC Facing Operation. So double click on this CNC Facing Operation and then I will save this. So here you can see location CNC Facing Operation. So I will name this as file as facing file or facing operation. So okay, I will name this as facing operation file. Okay, so the name is facing operation file and the location is CNC facing operation. So this is the CNC facing operation and I will save this. Now you can see that facing operation file is in this CNC facing operation. So this is my CNC facing operation. Here you can see the facing operation file is there. Okay. Then I will change this workspace into manufacturer workspace. And here you can see the units in millimeter. If you want to change the unit, you can change. Okay. Then the next is the setup. Okay. So what is actually setup? So setup means this is actually the first step in the manufacturing process. Setup is actually where you tell Fusion 360 what type of tool paths to create. That is a milling operation, turning operation, etc. Which Fusion models are parts, which Fusion models are fixtures, and how big the raw material will be. Fusion 360 will help you determine the size for your raw stock by examining the part model. You can easily add additional material to your stock model for rough cutting and work holding. Origin actually lets you define where 0 will be located on the part. And on the post-process tab, you can define the NC program number. That is, say, for example, 01234. Add a program comment to the NC header and select the machine work coordinate offset WCS to use. So here I will go with this new setup. So when I will click the new setup, you can see uh, three options: setup, then stock, and post process. Setup, then stock, and post process. So first of all, I will change this. Here you can see machine. You can select the machine. If I will select this machine, and you can filter this. So here you can see additive, that means 3D printing, Autodesk generic FFF machine. If cutting, you can see Autodesk generic cutting machine, and milling, Autodesk generic 3-axis machine. Turning, there is no machine actually is there, so I will cancel this. Okay, so setup option, I will go with this operation type. These are the 4 operations: milling operation, turning or mill turn, cutting operation, and additive. So this is actually a turning operation, so I will go with this turning operation. Then here you can see this. Here you can see work coordinate system, safe Z, then model, chuck, etc. Then next is the work coordinate system. So this is actually, here you can see the orientation. You can change the orientation. You can fix the Z axis. You can flip the Z axis, X axis, flip X axis, origin, etc. Here in this problem, you can see this Z axis will be, I will show you the top view. The Z axis will be exactly the center line of this workpiece. You can see this is actually the Z axis. That means this is actually correct. This is the center line will be the Z axis in the case of lathe operation. Then this movement, here you can see the X movement. This is the X movement. Okay, this is the front movement and this is the back movement. Okay, so lathe is actually a 2-axis machine. That means the axis of this lathe is actually 2 axis only. One is X axis and another one is Z axis. So Z axis will be passing through the center and the X movement will be in this direction. Okay. So for turning operation, the Z axis actually always point through the center line of the cylinder. Here I will not change any of the values. Okay, I will change the safe Z reference as, say, 150 millimeter. That means the tool that actually represents the home position. That means the tool will retract when doing a tool change. So I will change this offset, this safe Z value as 150 millimeter. Okay, so I will not change any other values. Okay, so because this is a first operation, I will not change any other values. Okay, I only change this. only this safe Z value. Then this next is go to stock. Okay, so here I will change the stock mode into, so there are different mode. So the different modes are fixed size box, then relative size box, then fixed size cylinder, relative size cylinder, fixed size tube, then relative size tube, then from solid, etc. So here I am actually using this relative size cylinder. So Fusion actually select will create a basic cylinder shape that fits our part. In most cases, you will want to add a stock for finish machining. So here I am selecting this relative size cylinder, and here you can see some offset, some radial offset. So here the default value of radial offset is stock offset is 1 mm. So this actually specifies the radial offset of this stock. So I will show the front view. Okay, so say for example, I will change this into 10. You can see this is the offset value in radial offset value. So I will change this value into 2 mm. So that is the radial offset value. Then next is the front side stock offset. That means this is the front side. So I will show the top view. Okay, so I will change this front side offset value to say 10. You can see. Okay, so here actually this point is actually represents the front. That's why this length is 10. So here this is actually my front side. So what is the next step? You have to change this axis to here. Okay, so I will change this axis to here. That means, okay, I will go with this work coordinate system. Then I will change the orientation, select Z axis, select Z axis / plane and X point. Okay, so I will the Z axis will be the center line. So I will go to the models option and here go to origin. So here this is my Z axis. So this is my, so here you can see the Z axis, that is the rotary axis is Z axis. Then again I will go with this front side offset. So here you can see, then I will go with the top view, and here I will change this front side offset. So here you can see this is my front side. So this is the 10 mm. Okay, so I will not need 10, so I will enter a small value, that is 2 mm front side offset. This actually specifies the distance to machine beyond the front side of the model. Then next is the backside offset. So what is the use of backside? On the lathe you need to have stock to grip your workpiece. So that's why I am using this backside offset. Say I will enter the backside offset value as say 12 millimeter. So here this is my back side offset. This actually used to grip your workpiece. This is actually used to grip your workpiece. So this distance is 12 millimeter. And at the bottom here you can see the dimensions. Fusion actually displays the dimension, the current. Now what is the current size of the cylinder? The diameter of the cylinder is 104 mm, and the length of the cylinder is 114.2 mm. Okay, so here last one, there is an option that is called a round up to nearest. This actually specifies the rounding increment for the stock size. So I will change this to 5. Okay, that means here you can see the diameter is 105 mm and the length is 119 mm. Okay, initially if this is 0, here you can see this is 104 and this is 114. So when I will change this to 5, here you can see 105 and length will be 119. Okay, this actually round up to the nearest parameter to round the stock to an even size. Okay, then the next tab. So I hope it's clear. First of all, I have explained the setup option, then I will explain the stock option, then next is the post process. So here in the post process, you can see the program name or number. This actually defines your NC program name or number. Typically, this number is the output at the start of the NC program code as the O number. Example, O, for example, this number is 1001. So the starting line of the program is O 1001. So I will change this into say 1500. Then here, if you want to add any comment, the program comment, this also will appear at the start of the numerical control program. I use this to describe the job or part number. Okay, so I will change this phasing operation. So just I will add a comment, phasing operation, phasing operation. Okay. Then next is the machine work coordinate system. This actually lets you select the work offset used in the numerical control machine to shift the 0. Typically, this is output in the NZ program as a G54 through G59, but this will vary between numerical controls or machines. 0 and 1 will output the first available fixture offset, 2 will output the second available offset, etc. like that. Set the work coordinate offset to 1. So here you have to just simply enter the work coordinate offset as 1. So once again, you have to fix your safe distance. Okay, that is actually 150 mm. You have to fix the Z axis, the X axis. You have to fix your work coordinate system. You have to select the operation type. Okay, then you have to fix the dimensions of your workpiece, the diameter and the length of your workpiece. Okay, and you have to change the machine work coordinate system, program name, program command, etc. Once this is completed, you have to click this OK. Okay, so then the next is you have to start the phasing operation. So the first step is you have to fix the setup. Then the next is you have to select the strategy, which strategy you are actually using. So here I am using the turning phase. So I am selecting this turning phase strategy. Okay, so I will select this. So what is actually a turning phase? This is actually a toolpath to remove the rough stock from the face of the cylinder. So I have to remove the material from this. This is the face of the cylinder. I have to remove material from this surface. That is the phasing operation. This can be a single cut for finishing operation or multiple cuts to remove bulk stock from the workpiece. After we select our tool from the tool library, we will cover the parameters used for clearance, multiple cuts, and cut transitions. So I have selected the turning phase operation. Okay, so here you can select the tool. So I will click. When you select the phasing strategy, you can see the first option is tool, then the second option is geometry, then radii, then passes and linking. Then so here I am selecting the tool. So I will select the tool. So when you select the tool option, so here in the left side you can see this is actually a turning operation. So turning sample tools you can see. So you have to click the turning sample tools, and here you can filter with the help of this tool category: milling, hole making, turning, cutting, probe holders. So I will select this turning operation. Okay, so from this turning operation you can again you can filter the type. So is it a general turning, boring, turning grooving, or turning threading? So I will select this turning general. And here you can see the tool CNMT right hand tool, CNMT left hand tool, etc. So I will select the first option, CNMT right hand. So I will select this, the first one, CNMT right hand tool. This is actually a standard diamond insert roughing tool. So if you want to edit this tool, you have to right click the, okay, so I will select this. Okay, so here you can see that your tool is displayed here. And what about this distance? Okay, you can see this is 150 mm. Okay, in the setup option, in the setup you have entered the safe Z as 150. That means this distance is 150. If you want to edit this tool, okay, go to this setup. So here you can see this is my tool. Just right click here. Okay, so once again, okay, yeah, so here you can see, you can right click here and you can edit tool. You can edit tool. Okay, so you can see the description, vendor, product ID, product link, etc. Then insert is actually, the shape is actually standard diamond insert roughing tool. Okay, so the details about this inserts: relief angle, tolerance, cross section, insert size, thickness, corner radius, etc., type, unit, material, etc. Then details about the holder, then the setup, then the cutting data, the speed and feed rates, and finally the post process. I will not change any values. I will simply accept this. Okay, and I will select this. Okay, so here you can see your tool CNMT standard diamond insert roughing tool is displayed in the screen. Then the second option, that is the geometry. Okay, here there is no need to select any geometry, because facing strategy assumes it will be removing stock from the front side of the part. So here, okay, so here nothing to no need to select any geometry, because that actually this facing strategy assumes it will be removing stock from the front of the part. Then go to the radii. Okay, so here in the radii option you can see 4 different radius: clearance radii, retract radii, outer radii, and inner radii. Okay, so this is the clearance radii, this is the clearance radii, and this is the retract radii, this is the retract radii, and this is the outer radii, and this is the inner one. Okay, so again, Fusion won't require any changes. If you experience any problems, just compare your settings to the ones in the dialog. All these values are in relation to the stock. No need to, we actually won't require any changes. Okay, then I will go to the passes tab. We want to check the multiple passes. So here you can see check the multiple passes. Okay, and then you have to enter the stepovers, number of stepovers. The stepover actually determines the amount of the distance determines the amount of material initial toolpath leave for the first finishing pass and for any subsequent finishing stepovers. So I will change the stepover to, say, I will enter this stepover to say 0.5. Okay, so here you can see this one. Okay, you also have an option to check finish pass. Okay, you can click the finish pass, where you can set additional cuts at a finer increment, but we will just take so I will change this into say 2 mm. Okay, I will change this to 2. You can see the changes. Okay, so I will change this to 1. You can see. Okay, so I will change this to 2. Okay, and then the last option, go to the linking tab. Okay, we control how the tool will move from one cut to the next. It also controls how the tool will lead in and lead out of the cut. The default lead in or out on a 2 mm linear move at a 45-degree inclined angle. Okay, so lead in here, linear leading length as 2 mm and the linear lead in angle as 45 degree. Here in the picture you can see lead in angle 0 degree, lead in angle 45 degree and angle 90 degree. This actually specifies the entry angle of the lead in move at the start of the cutting pass. The angle is in reference to the first cut. Lead in actually shown in the green color. So you can see angle at 0 degree, angle at 45 degree and angle at 90 degree. Then I will click the OK button. Okay, so everything is ready. Then the next step is you have to go to the actions tab and generate. When you click the generate button, the selected operation has a valid toolpath. Do you want to generate the operation anyway? So I will click this as button. Then I will go with the simulate. Okay, so that is the facing operation. So I will change this, say step over to say, and I will change the step over to say 0.5. Then I will generate this. Here you can see okay. So I will change this to okay. So this is the phasing operation. Okay, I hope it's clear how to select, how to create the setup option, then how to select the phasing strategy, then how to use this generate option, simulate option. Then the last two steps, that is the post processing. I will select the post processing and I will select the controller Fanuc. I am actually using the Fanuc controller machine, so that's why I am selecting this Fanuc option and turning operation. Okay, if you want to select any vendors, you can select any vendor. Here you can see the program name or number, then the program command is displayed here. Okay, and unit is actually document unit, and I will click the post button. Save this. Okay, so here you can see this is my CNC phasing operation, and here you can see the program number 1500, and here you can see the program command phasing operation, and this is my code CNC G code and M code for the phasing operation. So this is my code. So you can copy this code and connect it with your machine. Okay, and the last step is go to actions and click the setup sheet. Yeah, this is the setup sheet for program 1500 and phasing operation, and the document path is this phasing operation file v1 setup 1. Then about the setup, the work coordinate WCS1, then stock, the diameter 105 and the length is 119. Then the total number of operations 1, number of tools using 1, tool number 1, then maximum Z, minimum Z, feed rate, spindle speed, cutting distance, rapid distance, estimated cycle time, etc. Then you can see the details about tools and the operations. So here there is only one tool, that is tool number 1. Okay, the type, the insert details, everything, edge length, nose radius, everything will be displayed here. Then the operation is only one operation, that is the phasing operation. So only one tool and only one operation. So all the details about the operations, the tool, the setup, that will be in the setup sheet. Okay, so I hope it's clear about this, how to use this phasing strategy in Fusion 360. So once again, I have explained how to select the manufacturing workspace. Okay, I have explained how to select the sample files from the CAM samples. Okay, I have explained. Okay, so then I have explained how to save this file, how to change the units 2 millimeter or inches like that. Then how to use this setup option. Then selection of the strategy we are using. So here in this operation, we are actually using this phasing strategy. So this is my phasing. You have to select this phasing strategy for phasing operation. Then what is the use of this generate? Okay, then simulate and post process and setup sheet. Okay, so watch this video and practice this in your home. Thank you.